So we're just going to open POSPac Complete after you've downloaded that from the link I sent. I sped this little bit up a bit. It takes a few minutes to come through. But once you're open, just hit new project and just open a blank template, that's fine. From here, it's got this weird background. There's some bug with the TID being logged in. You can see here we don't actually need to enter a coordinate system down the bottom here, so I'm just kind of illustrating that that's not something we need to do. It's not something I've forgotten. It's just something we don't need to do. From here, I'm just going to open, we just need to import the raw data, and I'm just going to navigate to the raw data folder. So I went going to this TMX folder where it's all got all the raw data. You know, I open that one. I need the positioning data. So pos_1. Get to that. Open the raw, and there should be a TO4 file in this folder. With the longer runs, there may be multiple TO4 files. I'm led to believe if you just open the top one, that should import them all if there are multiple. If not, just open that one. And that will import directly into POSPac. Automatically, it'll look for ephemeris data from the satellites, orbit information. This is automatic. I've sped this up as well to save a bit of time in the video, but just wait through that until it's imported correctly. And this is what it'll look like after a few minutes. So you can see this is the navigation route. This is the data set that we did for the test demo last week. In that view pane, you can switch it to plan view as opposed to map view. That'll get rid of those weird tiles. You don't really need to know what's happening in the background. So from here, we go into the project tab and hit that Trimble PP RTX. This is the same as the GNSS inertial measurement. When we go through here, we're looking at these few settings here. The top one automatically populates these PP RTX is what we're looking for, so don't worry about that one. The next is the RTK corrections for this instance and all instances for post-processing. We'll be looking at the downloaded option there. From there, we need to go into the IMU context, change that to be on board. On board here. And then the bottom section, the heading sensor, leave the GAMs active. From here, you just hit run and that'll process for a couple of minutes. Again, I've sped that up. You'll get this small pop-up showing the metrics. This is not a great data set for the demo because we didn't have enough convergence time. So you can see the the float percentage and the no solution percentage. This data actually came out all right, but in the larger data set, you'll see a better fixed solution percentage come through. So just acknowledge that dialog. We can look at some QC results in a second, some more detailed ones. So that'll load through and do a few little loading scripts. From here, we've processed. So that's the full RTK post-process complete. You can see this is a quality. Oh, I've just forgotten to save this project, so I'm just going through to save the POSPac project. Again, similar with TBC, we want to save it in a location that is adjacent to, adjacent to the raw data, because it's pointing at the files relative to the file path. So pop in a name there, whatever makes sense. Let's save that. And you can see here, this is a path that we'll be interested in. So this is where that SBET has been saved in that location. This is kind of going to be pretty critical for us. This is what we're going to push back into TBC. So take note of that position. You can see here in the plan view, we've now got two trajectories, the green being the processed and the magenta being the raw nav position. So you can see that was successful. We don't really need to do too many more diagnostics in the plan view, but you can see they're large segments, but that is a kinematic solution, so don't worry too much about that. It does get smoothed as part of the processing. So from here, I'm just going to open TBC. This is what we're going to use to import our raw MXDB data. I'm just going to navigate to where that POS information was saved. So if I go into the POSPac folder, mission 1, proc or processed, there will be an SBET file in here. It should be called SBET _ whatever the mission was called .out. This is the file that we're really interested in. This is basically our post-process trajectory that we're going to use from here forward. So from this point in time, we actually need to reference this file location. So go in ahead of time and just copy the path or copy as path, and we will use that in a few minutes. Within TBC, once this is up and going, we'll start a new project as we would have shown you multiple times. This instance, I don't have my template set up, so I'm opening a blank project. From here, we will set the coordinate system using that grid button down the bottom. Again, I'm just going to use a recently used. And go OK. From here, I'm going to import that MXDB. So this is where it's important to actually use the import tool function and not just drag and drop. And it'll make sense in a second. When I locate to that raw data and click on that MXDB, I've got the option down here for a refined trajectory. And that's exactly what we want. We want to point towards that PP RTX solution we just computed in POSPac Complete. I've pasted that path location in there and just deleting those quotation marks. And from here, all we need to do is import. And this is going to import as we normally would previously, but instead of pointing to the nav position, the autonomous position that we captured in the field, we are going to be pointing towards that PPRTX trajectory. You can see here in the Project Explorer, my trajectory is an SBET solution, so a resolved solution here. Now, within mobile mapping, we can't look at those trajectory plots like we've shown you before, but you can within POSPac. So within POSPac, go ahead and open the reports pane, and that plots. They're the same plots that you would see, or we have shown you multiple times in TBC. These are the same plots that you can see. So you can see this is the solution we got, the average. You can see we didn't have that much convergence time. Ideally, we'd probably converge a bit longer. There's a few sections that wasn't ideal, but for the most part, the data is actually going to come through nicely. So from this point, what in your instance in particular, we don't necessarily want to produce one cloud for the whole run I suspect you've done multiple large runs. So from here, what we would do, rather than do that one cloud, is we want to select a run and we would split the run into multiple sections. This is a little bit manual where you actually have to just click the run and click a spot and then split. It will tell you those metrics of time and distance, but you just have to click on the plan view, unfortunately. I was hoping you could punch in a number here, say do it every kilometre or so, but you actually do need to just click on the plan view and click at certain intervals to break that up. You probably don't need to break it up like crazy, but you can see here what I'm going to do is just going to produce one of those runs as a scan. You can actually rename them in this properties pane here. So if you select a run, just rename them 1 through 5, or you can call it whatever you want. I just think the names get quite long once you start splitting a lot. So I like to simplify that and dial that down to just run 1 through 5. From here, we can generate scans. We can generate all of them or one of them. In this instance, I'm just doing one to show the workflow, cutting down the range of the scan head using these advanced settings. Cut it down to something a bit more reasonable. Depends on what you're using it for. In this instance, we won't colorize. I don't think you need it for your workflow. If you want to, we've run through that before, so no stress there. I had not saved this project yet, so it's prompting me to save my project into a location. So I'm just putting it again near our raw data, and from here I'm generating the scans. I've sped this little section up in the video just so we're not waiting for 5 minutes. And from here you can see we've got a solution. So the point clouds come through post-processed via PP RTX via POSPac. So yeah, this is the workflow. That's it. Please feel free to reach out if you have any further questions. Yeah, good stuff. Thanks.